So thus far, we've been very focused on just taking a derivative, finding that general function, but we haven't then done this next step of saying, well, what's the derivative at x is equal to 8, or what's f prime of 8, or even further, what's the equation for that tangent line? So this question, we're going to do all of that, so we can kind of see the manipulation to get this into something we can actually apply the power rule to, and then also how we find the equation for a tangent line. So first things first, we know whenever you see the word tangent, you're like, aha, this is related to the derivative. So if nothing else, I should be taking a derivative of my function. So let's start there. I also recognize that my function is kind of ugly. I know I can rewrite that cube root as a fractional, rational exponent, that 1/3. I also know that if I am multiplying two things that have the same base, that I can add their exponents. So this is the same thing as x, x to the 1/3 plus 3, which I have to think about for a little bit. That's 10/3. She hopes. All right, and so now we have something that looks exactly like a power function. It is a power function. This is just x raised to a power. No scalar multiple, no addition, subtraction, no sum difference, nothing to do except for a power rule. So I can go ahead and be like, well, might as well. I know tangent means I'm going to need a derivative. Let's go ahead and take the derivative of this thing, which is, I really don't like it when my parentheses are ugly, which is, let's bring that 10/3 down in front. We have an x, and I'm going to go ahead and take that step because when there are fractions, I get scared I'm going to mess something up. So it looks like we get 10/3 x to the 7/3. Gross. Gross. Ooh, this is going to be some good stuff. This is going to be a really good example. I'm already excited. So we know the derivative at a particular point is the slope of the tangent line. So if I want to find the slope of my tangent line, I just need to plug 8 into that derivative function. This is going to give me, come on, my slope of my tangent line. Okay. All right, so let's go ahead and plug in 8. This is where things are going to get exciting. So let's pretend also that we are, stuck on a desert island with some professor who doesn't allow us to use a calculator, because I really do think that there is some value in seeing how to manipulate this. So if you don't have a calculator, this looks scary as hell, especially in this form with the rational exponent. So let's try rewriting it back. Oh, it's still going to suck. Oh, I'm so excited. Let's try rewriting it back as a radical. So this is equal to 10/3. We have a third root, a cube root of 8 to the 7. Here's what students do that is inefficient. Like every student I've ever had in AP Calc wants to do this. They want to apply the power before the root, before that radical. And I think it's just because of how it looks within the notation. We typically write it with a power inside because it's just kind of cleaner looking. But this is the same thing as 10/3 to the cube root, or times cube root of 8, all raised to the 7th power. It really doesn't matter whether I do the power or the exponent first. It's a choice. Now, one of these is way easier to do by hand if you don't have a calculator than the other. And that's the cube root of 8. The cube root of 8 is much easier than doing 8 to the 7th power. Because if I evaluate that cube root of 8, I am looking at a lovely 2. Now I'm still a little bit sad because I should know 2 to the 7th power, but I don't. 2 to the 5th is 32, so it's 64, 128. I am not even going to pull out a calculator to check that. So that is wrong. That is just going to live forever in this YouTube video because I will not know. And then, of course, we could make this I guess, cuter. There's nothing there that is going to work. This is just a whole bunch of powers of 2 and a 5. So we cannot simplify this at all. That's the best that hideous slope is going to be. So that's part 1. Am I deeply regretting my choices? Yes. Because part 2 is we still need the equation for the tangent line. And in order to make a line, we need 2 things, a point and a slope. So right now, I'm half done. In fact, you might even say I'm 2/3 done because I do have part of the point. I know x is equal to 8. I need the y. And this is where I'm like, oh no. Really should think before I choose to do certain problems because this is the cube root of 8 times 8 to the 3rd power. So this is equal to whatever the heck 2 times 8 to the 3rd power is. Do I know what 8 to the 3rd power is? No. I am finally going to pretend like I'm going to stop pretending like I can do all math in my head. It's 502. 512 times 2. This is, woo! I guess I should have been able to do this. Trying to think, because that's fine. Whatever, I'm good. Now I'm really questioning my 128, but it's okay. Remember that game with the thing? Anyways, because this was really just 2 to the 10th power. But let's go ahead. We've got everything we need. We got our point. We've got our slope. Let's finish this up. Move my face out of the way. We don't need my face. With our equation for our line. You have lots of options. Once you're in calc, the simplest is to just use point slope. So as a reminder, point slope is y minus y1 is equal to m x minus x1. You'll sometimes see books like add more calculus-y stuff to this. I do not see the point in that. They will make this like f of x is equal to, like, you can't, I mean, if you want to calculus this, I'm going to erase it immediately, but I'm going to put it out here just so we can see it. You have like f of x minus f of whatever the heck we're looking for, right, that a value is equal to f prime of c, and then x minus. Does that like look nice? I mean, I guess if you divide both sides by x over c, you can see that limit notation kind of coming in. Remember that limit notation? And I guess it requires that you really understand. I don't know. To me, we're just adding obfuscation, but it is kind of nice when you think about the fact that it looks like that limit notation. But now we're ready to plug and chug. We have our y minus that value I just found, that 1,224. I will never give you anything this gnarly, is equal to, we have our slope, that's what we found, over 3, and we have our x minus, and then remember they gave us that 8. That was for free. So there is our equation to our tangent line. Now if I'm putting this, if I want to check this, I'm going to run over to Desmos. I mean, now we're getting off the desert island. Whew, finally. I gave up when I had to do 8 to the 3rd power. That's when I left the desert island. I paddled to some other land where there was technology. So let's think about what our original function was. So our original function was y is equal to, I don't know how to do cube root. Yeah, of x times x to the 3rd power. Right? That was our original function. We were interested in what was happening at that point that we found 8, 1,024, which is going to require that I really change the zoom on this bad boy. So let's go from 6 to 10, so 8's right in the middle, and then let's go from like, I don't know, 1,000 to 1,100. Okay, so my point's right there in the middle. Now, if we did a good job, in fact, let me zoom some more, because I'd rather be able to see if my function ends up being nice. I'm going to actually reduce this some more. Let's do 7.9 to 8.1. Cool. I just want to know that my tangent line like looks good. And when we get up to this sort of scale, it becomes really hard to tell if our tangent line is doing what we expect with the curve. Now, as a reminder, we had y minus that 1,024 is equal to my slope, which was my 1280, I believe, divided by 3, I hope. I'll go look back if it doesn't look right. And then x minus 8. Oh, we're so zoomed in that our tangent line and our curve look identical. We're not going to start seeing that they're not identical until we really zoom out, and then we can see them sort of coming away from each other. But that looks nice. Congrats us. So anyways, that is sort of the beefiest version of what could happen in terms of having to do a little bit of algebra ahead of time, and then where we could extend this by going and finding an entire equation for a tangent line.